All right, so today we're going to get into a little bit more challenging math, and hopefully that'll be good. This year is just so different because usually what I would do is I would kind of throw this out to you and tell you to figure it out and kind of let you flail, but that's kind of unfair with those half of us at home, and then we don't get to see everybody and all that kind of stuff. So we're going to give a little more support than we normally would, making sure everybody's good. But what I want to do first is I would like for everybody to turn to the specific heat capacity bell work number 1. And I would like everybody to try to do all of the questions by themselves. I'm going to give a nice hefty amount of time here to make sure that you guys can answer these questions, because this is pretty much what's going to be on your quiz on Friday. I have the key posted, or I also am going to go over this, okay? So I'm going to give you about 5 to 10 minutes here, take some attendance at home, see if there's any questions, and then make sure everybody's feeling good. So we're going over what is the heat equation, what are the units for each variable. You have that in your notes if you want to get that out. What is specific heat capacity? What is the specific heat capacity of liquid water? I have one Q is equal to MC delta T problem for you. Make sure you can do it. And then there's one more question that asks you about hot showers. Okay. So I'm going to put the music on quietly, meander around, see how everybody is doing. But I'm giving you a little bit of time to refresh what we did yesterday using the specific heat capacity bell work number 1. Good luck. Put the jams on. All right, we're almost done here. Perfect. Before I go over this worksheet, what I would like to do is kind of start a lab, and we can talk about it more once it gets going. But I would like for you to move kind of to the next page. I need one number before we can kind of get the lab where it needs to start. So what I'm going to do, and we'll talk about everything going on right now real fast, but I need 5 minutes of heating. So right where it says mass of the bolt, what I have here, okay, is just a bolt. I'm not going to tell you what it's made out of because I will give some stuff away, but probably have an idea. So it's just a bolt on a string, okay? A bolt on a string here. And what we're going to need is we're going to need the mass of this exact bolt. I have another bolt that we can talk about, but I don't want the mass of this bolt. I want the mass of the bolt I'm actually going to use. And then I need to boil it for a while. So what I want to do right now is I want to get that so I can get it in the water. So I'm going to turn on my scale here. The string is really light. It's kind of negligible on what we have going here. And I'm just going to place this bolt on here. 38.62 grams. So if you write that here, what did I say? 32. I can't even remember it from walking over here. 32.68. 38.62. Thank you. 38.62 grams. Okay. And all I'm going to do is I'm going to take said bolt and I'm just going to put it in this water. Okay. And I'm going to raise this up. I want the bolt sitting in the middle of this boiling water. Okay. We're going to come back to that. But all I'm doing right now, if I'm putting the bolt that was in room temperature and I'm putting it in boiling water, what do you think I'm doing to the temperature of the bolt? Taking it up. Okay. So we're heating up that bolt. All right. While that heats, we'll make sure 7:35, plenty of time to heat that bolt up. The heat equation. What are the different variables? Q is equal to MC delta T or Q is equal to MCAT is the heat equation. Q is joules. The amount of thermal energy or heat, whenever you see that. M, grams, or the amount of mass. C is this new idea of specific heat capacity, which we'll talk about here in a second. Oops. And then delta T is change in temperature, and you're always going to have degrees Celsius with that, correct? So this idea of C is specific heat capacity And the stuffy definition is the amount of energy is needed to change 1 gram of a substance by 1 degree Celsius. What I think of it as the cost to heat. Does it take a lot of energy to heat it, or does it take a little bit of energy to heat it? Okay, so that's kind of what we're thinking there. The specific heat capacity of water, your new favorite number that you're going to remember forever and ever and ever, is 4.18 per gram degree Celsius. That's how many joules, which is energy, it takes to heat 1 gram, 1 degree Celsius. Okay, so it's a lot of energy to heat up water. I had that water on here warming before you even walked in here, and it just now started to boil. It takes a lot of energy to heat cool water. Makes life interesting. All right, so the next question, and I'm going to give you time at the end of the period to go back and do worksheet number 1 because we didn't have a lot of time to finish it here. Copper has a specific heat capacity of, that's quite a number. Look at all those sig figs. Of 0.38452 joules per gram degree Celsius. How much change in temperature would the addition of 35,000 joules of heat have on 538 grams of copper? So you see a bunch of numbers. C to me is that nice big number. How much change in temperature? That means I'm looking for delta T. If I added 35,000 joules, that number comes out into the front. And 538 is my mass. So then what you're going to do is you're going to multiply these two things together here and then divide by 35,000 by that. The temperature that change that you will see is 169.19 or 18, however you rounded it, degrees Celsius. Does anybody have any questions on that? I guarantee you there'll be a lot of these practice problems. So by the end of the period, I'm going to have you guys go back and finish worksheet number 1 because we didn't get a lot of time yesterday to do some practice problems. Perfect. All right, so you have a guest over and they take a really long hot shower. Can you be like, oh, that's cool. That hot water tank will refill itself in 5 minutes. I'll be ready to take a nice long hot shower myself. No, it takes forever and a lot of cost. It takes a lot of joules to heat up water. Okay, water is 4.18 grams joules per gram degree Celsius. You have to wait a long time to get that water to heat back up. Okay, takes a lot of energy too. That's probably why your parents complain. They're like, I'm not paying that hot water bill, you know, going on and on to keep that. That's another reason why these new like tankless water heaters are becoming a thing, because it costs so much money to heat and keep water hot. So it's an idea. Okay. All right. So let's go and talk about what we're talking. We're going to crank up the math one more notch. Okay. But the quiz on what we're doing today will not be until next Friday. Okay. This is some harder math. If you get it the first day, kudos to you. If you do not, okay, we will keep practicing and keep practicing and keep practicing. All right. So this is what we're going to do today. And this is something I would have just given you a bolt and told you to figure it out by yourselves. But you also would have had a partner and you would have been doing the lab yourself and things would have been a little bit different. But I have a bolt here. And what I would like to know about this bolt is I would like to know the specific heat capacity. I'd like to know the C value, if you will, of this bolt. And the way that we're going to do this is we're going to do a little lab with it. So the first thing I'm going to do here is it says, prepare a hot water bath to heat the bolt. Check. We did that. Measure the mass of the bolt and the empty cups. Well, I have the bolt mass. And I'm going to get my empty cups here. Let's have everybody re-zero. Come on now. Here we go. My empty cups are 9.18 grams. Then I'm going to get 60 mils of tap water here. And it doesn't have to be super, super exact because we're going to take the actual mass of it, so that's good. Boom. Obtain 60 mils of cool tap water. And then I want the mass of this tap water. So what I want you to think about, maybe those of you at home can't see this. Move the feel over. There you go. Excuse me, microphone. All right. So I know the mass of the cups, correct? And when I pour this water in here, now I have the mass of this is, oh, well, get out of town. There we go. Okay. Now I'm going to take my mass of my water and I'm going to add it into my cups. Let's do some critical thinking here. Now it says it's 70.35 grams. But that is the mass of my cups with water. How do I know just the mass of the water? What should I do? Thank you. I'm going to subtract. So let's get our calculators. And we're going to say 70.35 minus 9.18, which is taking the cups away. My 60 mils of tap water, the mass is 61.17 grams. Okay? All right. Now, what we are going to do next is place the bolt in the hot water bath for 5 minutes. We're putting that at 35. Oh, we have plenty. We got 10 minutes on that. Heat for 5 minutes. Check. Right before putting the bolt in the cool water, obtain the temperature of the cold tap water. So let's do that next. Here's my tap water. Grabbing this temperature for you guys. Here we go. .7 degrees. And then it says, quickly transfer the bolt to the tap water to get the temperature when the number settles on the thermometer. Okay, so just like our students did yesterday, I'm going to take this bolt in boiling hot water. And I'm going to go 1, 2, quickly as I can. What is it going to do to the temperature of the water if it's a hot bolt in cool water? It's going to make the temperature of the water go up. Very good, very good, very good. So we're looking at, beautiful, let it settle, let it transfer all of its heat. All right, we'll call it 27.0. Okay, perfect. Now, what I want to do very quickly is I would like for you guys, and those of you at home too, maybe I'll call on you sometime and see how you're doing. Ooh, somebody came. Who came? I'm excited. Ooh, I see you. I would like for you guys to think about this, okay? You guys are in an honors class. I think you guys can struggle with it for a really quick second. 2 things, okay? I want to know the C value of the bolt. Okay, so it says calculate the specific heat capacity of the bolt. However, I don't know a lot about the bolt, okay? But I do know a lot about the water that was here, okay? So the interesting thing in the law of conservation of mass is going to tell me that any energy gained by the water is equal to the amount of energy lost by the bolt. And if you can do to yourself 2 Q calculations, can you figure out how much energy the water gained? Then if you know that, can you tell me the C of the bolt? I think it's very interesting. But one other thing I want to kind of point here, and the reason why I can say this, here, this is the law of conservation of energy. So what we're going to pretend in our class is that every joule from the hot water or from the hot bolt went into the cold water. They are absolutely equal, okay? Didn't lose anything to the air, all that kind of good stuff. So everything was equal there. And the other thing you want to write down, you know the initial temperature of the water. Why did I boil that bolt? What temperature does water stay at when it's boiling? Water boils at, good, 100 degrees. So the bolt started at 100 degrees Celsius, okay? So the idea is that the bolt was at 100, came down, the water was at 21.7 and came up, okay? So that's going to help you get some delta T's. I just want to see, and maybe you can't, that's fine. I want to see who thinks that they might be able to tell me the specific heat capacity of the bolt. If you know nothing else, I want you to just, at least on your paper here, write Q water equals. And then you know that Q is equal to MC delta T. Can you do the mass of the water? Do you know C of the water? Can you give me a delta T of the water? And then if you understand Q is equal to Q, can you then tell me? So I'm going to kind of take you right to the edge, and then I'm going to throw you guys off. I'm going to walk around, see how you're doing. Those of you at home, if anybody has an answer in a few minutes, I would love, love, love to hear it. So we're looking for the C value of the bolt. This is tough, but I want to see if you can figure it out. Okay, tough stuff. Let's see where we're at. I always have at least a few people that can figure this out. So let's see. You can at least figure out, I know you can get the Q of the water. That you have everything on your paper you need for the Q of the water. I like it. All right, I see a lot of people that are halfway there. Let's talk. Okay, let's talk, let's talk. And I'm going to have to do these numbers right along with Chuck. So let's make it happen. So the first thing that we know, and it's probably going to be on your lecture questions here, the law of conservation of mass says, hey, whatever Q my tap water gained is exactly equal to my Q that the bolt lost. I also know that the temp of my bolt started at 100, okay? Then you're going to follow this kind of procedure here. The mass of your tap water, which we said was what? Again, we're doing this on the fly. We're doing this live. Mass of the tap water was 61.17 grams times 4.18 times, I need the delta T of my water. So my water ended up at 27.0 minus 21.7. So my delta T of my water is 5.3 degrees. Do we agree with those numbers? Okay. So I'm going to put this 5.3. Okay. Hopefully you guys can get at least that first Q. So let's do that. So 5.3 times 4.18 times 61.17. So did we all agree that the Q for the tap water is 135.516? Okay, that's how much energy went into my water. That same energy came from the bolt. So I can say, how much energy did the bolt have? 1,355.16 joules. Okay, that's the exact same number. So now let's set up for a Q of the bolt. I know the Q of the bolt had 1,355.16 joules is equal to, now here's where things get tricky. I need this to be equal to the M. So maybe I should do it under here so it's a little easier to read. 135 is equal to, the mass of the bolt was 38.62 grams. I'm looking for C and the delta T of the bolt. This is the number one thing And it's once you know it, then it's easy to do. The bolt went from 100 because it was boiling to the mixed temperature. So what was the delta T of my bolt? Well, let's see. What I need to do is I need to do 100 minus 27, and the delta T of the bolt was 73 degrees. So now I'm going to do 73 times 38.62. So now I get 2819.26 C, if you will, is equal to 1355.16. In order to get C by itself, I'm going to take my 1355.16 divided by 2819.26, enter. 0.48, we'll call it that because we're going to joules per gram degree Celsius. Okay, so it's just 2Q calculations because of the law of conservation of mass. If I know the Q of one thing, I know the Q of the other thing. And if I boiled that for 5 minutes, I know it's at 100 and it comes down. So bolts are actually made of iron, and iron's specific heat capacity is 0.45. So we were hot dog only about 3/100ths off of the actual thing. So if you would like, we're going to do a few things here. We still have 10 minutes left in class, so we're going to do a series of things. I have another set of data. This is like what if you were absent. If you would like to try this again, because this calculation is going to be on your quiz next Friday, and we're going to do coffee pot water tomorrow. We're going to practice this a lot. But if you would like, I'll leave this up here. Here is some more fake data if you want to run the calculations again. I'll leave that up. Or I also want you to do your lecture questions. That's also an option. Or I want you to go back and finish the worksheet from yesterday. So there are 3 options of what you can do in the last 10 minutes. Let's do the lecture questions. The lecture questions. And you might want to jot that down. I mean, you have to have our answer, but lecture questions. Finish the worksheet from yesterday, or if you would like to try to run those calculations again, you should get about 0.449 joules per gram degree Celsius. You should get right around that again. So I don't care which one you do. I'm going to walk around, see how you're doing. I would like to talk to everybody at home, make sure they're feeling good. But again, if you would like to maybe get a different color of ink, whatever you would like to do, you can run these calculations again, do your lecture questions, or finish the worksheet from yesterday. And the key is in the Monday folder on that one. Okay. All right. Put the jams on. I'm going to check with everybody at home.